Hi everyone, I'm Aiden, here to talk to you today about developing desktop apps with Electron and Ember. Before we get started, has anybody here written a hybrid app before, whether with Electron or Cordova, something using JavaScript to ship as a native app? Seeing a couple of hands, sweet. So for those of you who haven't, I'm going to quickly go over why developers would write a hybrid app, just so you could figure out if this is for you. We'll talk about what's coming up, and then we'll dive straight into the more deeper, in-depth material. So a couple of things or reasons why devs like writing hybrid apps. One is App Store distribution. If you want to go and write something that ends up being published in the Mac App Store or the Windows App Store, you're going to have to write a native desktop application. If your app ought to be decoupled from a long-lived browser app, let's say you've got a mail client that you want to permit the users to leave open even when they close Safari or Chrome, you're going to want to wrap that web app as a desktop app so they can treat it as a separate process. You also might want to use the system UI, like the alerts or the menu or taskbars. So again, in this fictional email client, you might want to use just sort of like a notifier with a little badge up in the top menu tray. And again, writing a desktop hybrid app allows you to achieve this with your existing webmail client that you might have written. And lastly, if you want to use system resources like the file system or the GPU, let's say, again, to more tightly manage attachments with this fictional mail client, you can, again, use the system resources and more aggressively cache attachments or other files. So today, what we're going to talk about from the lens of hybrid apps are first an introduction to Electron, focusing mostly on what it is, why it's used, and the architecture it provides you. Second, we're going to talk very briefly about ember.js, a front-end framework that we use a lot at Isle of Code. In particular, we'll be talking about ember-electron, the tool that we use to marry Ember projects with Electron projects. We'll follow that up with some quick demos about building an app with ember-electron, just reviewing a couple of the core commands and build flows that it provides. Talk about extending your Electron app, so a couple of additional features that you might add to it. And then if there's time, we can jump into a couple of advanced topics, notably how you might build your own native plugins so that you can wield full control over the host system. But before we dive in, hi, I'm Aiden. As Ray mentioned, I'm one of the partners and sort of cross-language specialists at Isle of Code. You can find me on the Twitters, the GitHubs, a bunch of other places online with the same handle. I'm one of the maintainers of ember-electron, which is, like I said, the project that we use to marry or to run Electron projects from an Ember project, with some contributions elsewhere in the Electron and hybrid ecosystem. And when not hacking, because we're all people, aren't we? I am often on my bicycle, seeing live music, or making food. So about Electron. Electron is an open source framework that allows you to compose these cross-platform desktop apps using Node.js APIs and Chromium windows. We'll come back to this last bit in a second. Electron was originally extracted from GitHub's Atom editor, if you've seen that before, if you use it to code. It's really just running a web process as the GUI. This is why you can do a lot of work extending it with JavaScript or CSS. It's really just turtles all the way down. Electron was sort of grew out of two other experiments in the hybrid desktop space called Chromium Embedded Framework and NWJS. Neither were perfectly applicable for the Atom use, so they ended up sort of forking off of Chromium Embedded Framework, taking a bunch of learnings from NWJS and using these philosophies to sort of write their own hybrid ecosystem, which then they then extracted to what was first called the Atom shell and then cleverly renamed to Electron. Some notable examples of Electron apps that you might be using already today are Atom, Slack, Brave, the ones that you see on the screen here. In terms of architecture, Like I said before, Electron offers you simultaneous control of the Node.js runtime as well as Chromium runtimes. What this means is it runs a long-lived Node.js process as sort of its main process loop in the background, which can then, on the right commands, open browser windows, which are embedded Chromium processes, as renderer processes. You typically will open only one renderer process for an app, and that's the main GUI that you'd use. But we've also worked on apps at ISLE where, for example, we'd be hooking into a networked file system in the main process and then listening for keyboard events or certain like drag and drop events, and then using those information from those events to open several browser windows as well. So there's a full spectrum from 0 browser windows, 1 browser window, or several. Electron comes prepackaged with JavaScript wrappers for a number of the common HostOS APIs that you'd use. I've mentioned a couple of these before, so system tray. We'll be talking about auto-update a little later in this talk, as well as keyboard shortcuts with and without app focus. There will be a demo of that in a couple of slides. Many of these prepackaged JS wrappers are restricted to the main process because you're concerned about memory leaks and security. For example, if you're using, let's say, a keyboard shortcut and you've registered a keyboard shortcut, you want to do that in the main process so that you're able to clean up, or you're encouraged to clean up at the end of the app's run, rather than have that listener linger after a browser window may have already been closed. So Electron's architecture actually protects you in a lot of ways from making easy mistakes when it comes to memory management or HostOS resources, requesting permissions and cleaning up after yourself. Lastly, about Electron, there is a project in the community called Electron Forge that if you've used Electron and not seen this yet, I highly encourage you to check this out. It is a CLI that wraps the best-in-class community tools around packaging and livereload or generating your distributables like a .exe, a .app, a .zip that you can distribute on the web. And it exposes them all with, from a single source of, from a single CLI, which also allows you scriptable access into all of the APIs that the CLI uses. I'll get into why that's important in just a minute. Couple of disclaimers for those of you new to hybrid. First off, the Electron and most hybrid apps, because they are serving JavaScript or single-page applications, HTML CSS JS payloads from the file system, you generally want to avoid prefixing your paths with a slash. This is sort of moving out of the norm in Electron as more people are starting to register a protocol at packaging time, so they can you can just sort of serve at my app : / your path, which then allows you to reference relative assets. This comes from how D3 is often embedded in an application. It seems to break in a lot of Electron applications unless a protocol is registered. Second, the architecture should minimize any platform-specific code. You're writing a hybrid application so that you can go and write once and have it deploy to several targets. So the more you can do to leverage that, the better. You don't want to go and start hot swapping in a bunch of files based on which platform you're using willy-nilly, because that leads to, or that can very easily lead to situations where you don't have certain files, or you need to keep all of these separate heads in sync. Third, you need to be very careful in a hybrid space because you have full control of the host operating system. This means that if you're loading remote code in your browser windows and starting to run remote JavaScript, you're actually running in a blessed environment that has access to basically everything that a standard Node.js proc would. So you have full control over the host system, which means that you do not want to be executing malicious code because you can install some really dangerous stuff. Lastly, memory leaks are a major issue because the app is long-lived. There is no request response cycle. I know Alex has a lot of content on this in the Cordova space because memory management is particularly important in mobile. So I'll just call out two of the most frequent culprits here. So ember.js is an open source front-end framework for ambitious web applications. It's the framework that we use most at ISLE for several reasons, but in short, it helps us with some very strong primitives around routing, its ORM, and its rendering pipeline. Most importantly, though, the CLI offers very mature tooling for build processes that you might want to hook into as an add-on or separate library. Another strong point for Ember is that it encourages convention over configuration. So it's very easy to sort of point to ember.js documentation when you are otherwise confused about how something might be running in your GUI app versus your main process app. High level, we generally recommend using single-page application frameworks with Electron. Regardless of if you're using Ember, at least choose something like a React or Angular or Vue. These offer shared context to your UI code, so it batches all of your UI code together with a strong set of community conventions that are already documented somewhere and that make it easier to bring someone onto the project. It also enforces a clear divide between the renderer work and the main process work because it's much easier to picture the Vue.js app or the Ember.js app separate from the Electron app if they are using separate frameworks under the hood. If you're just sort of writing your own scripts or if you're just sort of writing your own from scratch for both of the processes, it ends up getting a little confusing as to where you might be putting certain files, and you start conflating a lot of these resources. Third, you can benefit from the upstream performance work and feature work that enables your GUI, the GUI side of your application to do more faster. And lastly, Electron Forge even ships with React and Angular templates. So you can very quickly start up your Forge or Electron app with one of the other SPAs if you're really bent on not using Ember. So ember-electron, as I've mentioned before, is a tool that marries Ember's CLI with the build processes for Electron applications. It wraps the Electron workflows from within Ember's CLI. The 2.x series proxies all of its operations via the Electron Forge APIs. So we're using the same tooling that would be used. For the rest of this talk, we'll be demoing from the same tooling that you would be using with a React or Angular app, just running through the Ember build pipeline as well. You can think of this as just sort of appending Forge to whatever Webpack script or gulp file you might have for your app. Ember-electron provides you with an Electron-aware testing environment, which is very helpful when you, let's say, want to acceptance test some work that is interfacing with native APIs that may not be available if you're running through a standard sort of like QUnit or browser-run test suite. And lastly, it was initted by a guy named Felix Reisberg, who is now at Slack and part of the Electron core team, and maintained by myself and a number of other lovely people in the Ember-Electron community. So building an app with Ember-Electron, let's say we want to look at some code, right? So we've got an application that we've already built, and we want to init it with Ember-Electron. It's really simple. You literally just tell it to, you tell Ember to install Ember-Electron, or if it's already been installed, you generate Ember-Electron. This does a number of things. We can look at it in a diff in a moment if you'd like, but basically it introduces an Ember-Electron directory to the root of your project. It inits a main.js file, which is what runs your main process for you. It reads the config data from Ember-Electron, and like there's a .dot file in that directory. And then lastly, it adds the ember-electron directory to the build pipeline for all proxied ember-electron commands. So what this looks like in practice is, first, let's look at over here. We've got, where's the pointer? There we are. Over here, we've got the last commit on this app before Electron was introduced. Over here is the first commit where we installed ember-electron. What that looks like, where is my cursor again, is, hello, quit. What this looks like is head 3, head 2. So as you can see, we've created this ember-electron directory. We've got our main.js. We also have these platform-specific resources directories. Here is our Electron Forge, so ember-electron.electron forge. Let's mute you. And we've got some config details saying which makers we want to be using. So we can use a zip here to build an executable. We can use output Debian packages or RPM packages. We've named the project Super Rentals. There's an icon. There's a bunch of config data in here. More about that on the repo's readmes. Next up, now that we've initted the application, we want to actually run it. So this is as simple as running ember-electron. This will build the app to a temporary directory and symlink the dependencies. It runs the built JavaScript with the pre-built and compiled Electron executable via the Electron Forge start APIs. It then watches the Ember app and the ember-electron directory for changes, so it'll live reload on any changes made, which is really helpful when you're trying to debug something live and quickly with an iterative process. It'll then install the Ember inspector to renderer windows so we can inspect data on the page, and it has a couple of useful options. So here is what that app looks like when we run it. I've just aliased E to Ember. Don't mind me. I like saving time. And we see it building here. And in just a moment, we have an Electron app that opens. Hello. So we can see it's called Super Rentals. It's going a little slowly. But this will load up. What? Where are you, Super Rentals? Apparently, you are not liking me today. I can show that in the built package afterward, I guess. So once you have a working demo application in your development environment, you'll want to package it and distribute it to other people on the team or perhaps your end users. So this is just like with that live reload shell. You call a very simple terse command, ember-electron package. There's also a couple of equivalents, like make will make your distributables, which are safer to go and distribute on the web. All of the make and build commands inherit from the same pipeline. So really it just sort of spits out depending on what sort of output or final chain you're looking for in your build pipeline here. So this will build the application to a temp directory. It will then install all of the dependencies to the application. It passes the built temp dir to the Forge API and cleans up the temp directory while we, oh, hello, you're still here. Where is that? Hello. Ember-electron package. What's going on? Don't send. Package. And we're going to tell it to package for development because this app does not like production build due to its use of Google Maps APIs. So this will go and build some things. While this builds, we can go and look at the options that you can pass in while you're building. You might want to pass in the environment to say you want a development build versus prod. You can tell it which architecture or platform you're building for. You can skip the packaging step if you already have a bunch of output distributables so that you can run a little faster. You can also specify a different output path or what targets you'd like to build for. So here we go. We've compiled the application, prepared its native dependencies, packaged the application, and it lives in Electron out. So here we are opening the application. Of course, you are not liking, this might be, I'm just going to blame conference Wi-Fi for this one. But we have the application there, and what you'll notice here is that it's using a fancy icon now with a real name. So lastly, testing. As I mentioned before, ember-electron test also exposes a test environment for your application. It passes the arguments to an ember test command and then a task runner that runs your test suite from within the Electron shell. It also permits, like I said before, acceptance testing the main proc behavior. So flipping over to terminal once more, you can call to Electron test, and it will build and open up the app in a test window right here. And I'm not even going to try waiting for that one this time. So now that you have a built Electron app, you might want to extend it with a couple of additional features. So one that we added in the app that is apparently deciding to beach ball today is adding some shortcuts and dialogs. So the shortcuts and dialogs are, like I mentioned before, some of the APIs that are restricted to the main process. The preference for these is to handle them in your main.js. Though you might want to or need to handle them within your browser window, there are mechanisms to do that as well. There's also several types of dialogs, from show open dialog to save dialogs, message boxes, and error boxes. What a diff looks like in practice is something like this. Let's clear you. And we can go and look at the get diff head to head. So you'll see that we added over here the dialog and global shortcut to our destructuring of the imported Electron object. And then we simply register a global shortcut on Command or Control T, which will show a message box asking what we call our fair city. And being from Toronto, you might mistakenly call it the 6, and please don't do that. The next sort of add-on that you might want to do is, like we saw, the app icon. The icon is read from the build processes working directory. So this is not something, as you'll see in a moment, this is not something you can go and sort of add to those resources platform-specific directories. They are added. I added them to a icons directory in the root of your ember-electron dir. You must create your icon files first, so there's platform-specific icon files. You will then add the config to the packager options, as we'll see in a moment. Or you can also, if you're running on Linux, you can add the icon path to the browser window in it from within Electron.js. What this looks like in practice is, let's leave you and get diff, head that one. So we see here, we've simply added the icons tomster to the packager config in the config file I demoed before. There's a couple of new files here. And last but not least, in the Electron main.js, we've added, when we create a browser window, checking if the platform is Linux, and then otherwise referencing the tomster.png. Lastly, a question that we frequently deal with is how to auto-update a Electron app once it's been installed on a host system. First off, before you do anything with auto updates, app signing is very strongly encouraged because you're toying again with your host, with your user's host operating system, and you want them to be able to be confident that the app they're installing automatically comes from the same publisher that they installed from initially. This prevents, again, remote code injection or possibly another app coming in and spoofing your binary. You'll want to configure app signing, again, in the config file that I demoed earlier. For Macs, you add the OSX sign parameter to the Electron packager config. In Windows, you actually configure this within your Electron installer config. And in Linux, you pray to Cthulhu. The reason being, Linux actually depends on, or Linux auto updates depend on which package manager your flavor of Linux uses under the hood, and how you configure your package manager's repository. So for example, if you're using apt versus yum, the approach will differ. High level though, in Linux, you'll want to learn how to publish for your system and then use a cron job to just automate the process using your system's package manager. You then make the executable using ember-electron make, and then you can publish it either via SCPing the built distributable somewhere, such as an S3. You can also publish it via GitHub release. Now that you have a published artifact that is your app, Mac and Windows apps can auto-update with Squirrel, which is sort of an automated update process that comes with a pretty strong server environment called the Nuts server. The Nuts server will proxy and cache your distributable assets. So from S3 or from GitHub, it will inspect what releases you're publishing and always be able to serve the most up-to-date version of the app. Then in your main process, you'll want to call the auto updater to check for updates. One helpful tip here that I've seen a lot of beginners have to work back from their code is the check for updates actually checks for the update and downloads it in a single operation. This may not sound awful, but the other recommendation within the Electron community is generally to quit and install immediately once the application is downloaded, again, so that any possible vulnerabilities are not able to go and inject themselves into the apps, the newly downloaded apps code. It just keeps everything you're running safer for the host OS. We frequently actually manually check the Nuts server for whether or not a new update is available and then download it. If you're on Windows, you must also handle the Squirrel events immediately on boot. Squirrel will issue events saying that it's your first boot or you're running on an update, and you need to be able to, your app needs to handle those in order to not leak memory, crash, or do worse things to your host OS. And seeing how we're nearing 30 minutes, I could go into some advanced topics, so building a custom plugin and what JIP, NodeJIP, and NaN are. But I guess I can also pause here and see if anyone has any questions on material covered so far. All right. Looks like we'll be talking about the custom plugins then. With regards to custom plugins, they'll require a bridge from JavaScript to native code. So you'd write a custom plugin when you want to go and use something like the file system or the system tray, but an existing plugin isn't shipped by the Electron project, nor is one available via NPM. So if you want to use, for example, a printer, which we use in some of our projects, there's a strong library called Node Printer or Printer. I can't recall which one is the more up-to-date one. But one of those is up-to-date, one of those is deprecated. And we use that to go and wire into the locally running cups driver on your host operating system. And that's something that's just available as part of the Node ecosystem. But let's say, for example, you want to write a native plugin that does some operations using the host platform's local tooling. So a package you might be downloading using Swift packages, or a library you've found that works on Linux or Windows that doesn't yet have a Node or JavaScript wrapper. So for example, here's some very small sample code. But basically what we're looking at here is somebody is trying to go and call either the function world or world async on a module called hello. This returns a string, and we just want to make sure that the response from world and the response from world async match. That's what this test suite runs. To do so, you'd use a tool called JIP. JIP stands for Generate Your Project. It's a tool built by Google and as part of the Chromium project. It's what they use to be able to build the Chromium, Chromium browsers on all of the different operating system platforms that they ship for. It's kind of analogous to CMake, and while it's been deprecated for a while, in fact, the Google and V8 communities are moving to a tool called GN. The Node community is still locked on JIP for the time being, so if you're building a JavaScript app and you need to be writing a custom plugin, you're kind of stuck with this deprecated tech. It offers you a declarative syntax to process your input files and whatever options you're passing to the native the native build tools, and then it will return you an executable or a library. So this is the example binding.jip file that we used to build the hello plugin from the last slide. You'll see that the target's name is hello world. So in the next slide, actually right here, you'll see, nope, in the next slide, you will see the how hello world is required. Basically, the JIP file will then parse and pass the input files, so the source hello world.cc, into your native platform's build tooling, whether that's Xcode or VS Code. Node.jip is the Node.js binding library for JIP. It will install the necessary headers and libraries that allows you to expose the JavaScript to C++ interface, moving from JavaScript to your JIP-generated project. Here is an example package JSON from a project that uses Node.jip. You'll see that on install, there is we're calling to Node.jip rebuild. That makes sure that the project that the native plugin is built for the currently running operating system. You'll also see that there is the dependency there of bindings, which is what we use to normalize build paths across the Node.jip versions and all of the different versions in the Node, all of the different versions over Node's lifetime. Effectively, JIP will package two different directories, and the binding file might be found at different locations of the required module. So bindings, as you see over here, where we're exporting requiring bindings and then hello world, the name of the target we saw in the last slide, that allows us to go and require hello world regardless of which version of Node it was built for or with. The other dependency you see there is nan, and that is a plugin that decouples your plugins code from Node versions as well. So this full system of JIP, Node.jip, and nan makes your plugin code resilient to changes within the Node ecosystem over time. Nan will then normalize your C++ types, your methods, and offers you some macros to give you a common surface regardless of if you're working back to Node 0.12 or you're on something more recent like a Node 6 or 7. So this is a example of a C++ header file that is using a bunch of nan macros, such as the nan method there, the nan types of the callback, and I believe, yeah, it includes nan.h up at the top. I have a blog post published on the Isle of Code blog with a bit more about JIP, Node.jip, and nan, and all of the sample code you're seeing today. So if you'd like to go and try running your own Hello World native plugin across a JavaScript to C++ boundary, all of the resources are there at blog.isleofcode.com. So with that said, I'd like to summarize what we talked about today. First, Electron is a proven and popular library that's used to create hybrid desktop applications from a single-page application payload of HTML, CSS, and JavaScript. It offers you a painless integration with ember-electron, and Electron Forge is also very helpful if you're deciding to not use Ember in your project. Electron allows you to use any system or server node module, like FS, in all of its processes, whether you're running in the main proc or the browser window. You still have access to things like FS or path or any dependencies built into your application. And lastly, you can write native plugins to pwn all the machines. So that's it for today. Thank you all so much for listening and nodding and paying attention. I hope you have a bunch of luck with your Ember, Electron, or just Electron hybrid apps.